Hello everyone, welcome back to another session. In this tutorial, we will be exploring one of the most commonly used functions in data science, importing and exporting data between CSV files and Pandas DataFrame. Here, today we will be exploring these two functions, read_CSV and to_CSV, and some of the important arguments of these two functions. Let's get started. So today's topics are importing data from CSV files to Pandas DataFrame and exporting data from Pandas DataFrame to CSV file. First, what is CSV file? The full form of CSV file is comma separated values. It's a tabular data that has been saved as plain text where data is separated in commas. That is in CSV format. So this is an example for CSV file. We can create a CSV file using a notepad or by using Excel sheet. And when we save the file, we have to give the extension CSV. If you are creating the CSV file from Excel, while saving, you have to give the type as CSV. So here each row of a table is stored in one row and the field values of rows are stored together with commas after each field value. No comma after the last value. This is an example for CSV file. This one is created by using a notepad and this is the same file opened in Excel. Creating a CSV file. First we type the data in MS Excel or Notepad, select the file and using the save as option you can save it as a CSV file. So the first one is importing CSV to DataFrame using read_CSV. From CSV to DataFrame, how to import the data from a CSV file to a DataFrame using the function read_CSV. Read_CSV belongs to Pandas library, so we have to import Pandas first. Read_CSV is used to bring data from CSV file into a data frame. The syntax is pd.c. We wrote pd here because it belongs to Pandas and we need to write the import command, import Pandas as pd. After that, pd.read_CSV, then the file path. Now what will happen? A data frame will be created using the CSV in this file path. Okay, we have to give the file path means the name and the location of the CSV file. Here, this is the CSV file. In the CSV file, you can see 4 different rows are there, right? Ria, this is Roman number 10A, Alvin, 12B, Sneha, 12B, Ben, 12C. They are separated by commas and after the last value, there is no comma. This is a CSV file. Now, when we pass the CSV to a read_CSV function, see, df equal to pd.read_CSV. It belongs to read_CSV belongs to Pandas library. That's why we write pd.read_CSV. What has to be passed? The location of the CSV file. Where we store the CSV file in our system, that location has to be passed. So here, how to find the location of this file? See, my file is here. Example.csv. So right click the file. Here you can see properties and from here you can copy the location and you can paste it there. / the name of the CSV, that is example.csv. And you have to replace the single slash by double slash. We know this is a escape sequence in Python. So we have to replace the single slash by double slash. This is how we give the location. Then when you print df, created data frame will be printed. See how it will be created? The first row of the CSV will be the column header. See the column index, they are the first row of the CSV. And what about a row index? Row index will be created in the data frame. The default value 0, 1, 2. See for the first row will be the column index of the data frame. And these are the values. Next is attributes of read_CSV. So read_CSV function is used to create a data frame from a CSV file. It belongs to Pandas library. So how to create? df equal to pd.read_CSV. Then you have to pass the location of the CSV file. Now to specify new column headings, use names attribute. So when we create a data frame from CSV file, what will be the column header? The first row. If you want a new column header, which is the argument used? Names. See, when you use names equal to sequence of values containing the column names. And the number of values in this sequence, in this name sequence must be same as the number of columns in the data frame. I mean the number of columns in the CSV file. So df equal to pd.read_CSV And when we pass names equal to name, class, section, a data frame will be created with the column heading as name, class, section. See the data frame, name, class, section. In the previous one, when we did not pass names attribute, what happened? The first row of the CSV became the column header of the data frame. Right. Here, when we use the names function, we can give new column heading. Next, header attribute. Next one is header attribute. It defines which row acts as the header. By default, the value of header is 0. So here to specify default column values like 0, 1, 2, 3, use header equal to none. If we use header, if we pass the value of header as none, what will happen? The column index will be the positional index 0, 1, 2. So if we want positional index as the column index, we can pass header equal to none. Now if we pass header equal to 0, what will happen? The first at the 0th row index, which are the data, that will be the column index. Here data, which are the data? RIA 10A, that will be the column index. If we pass header equal to 1, at the row index 1, which is the data, that will be the header of the data frame. So header attribute is used to specify the default column names. If we pass header equal to none, it will be the default column values, that is the column index. And we can define which row acts as the header. And we can give a particular row as the header by using header equal to then the row index. Next attribute is skipped rows. It is used to skip the rows from the beginning. If we want to skip some rows from the beginning, we can use the attribute skipped rows. See here we have created a data frame by passing the argument skipped rows equal to 2. This is our data frame. So what will happen? The first 2 rows will be skipped. Which are the first 2 rows? See 1 RIA 10A, 2 Alvin 12B. That will be skipped. And we will get this. These are the 2. So by default, we know when we create a data frame from CSV, what will happen? The first row will be the column heading. So this Neha 12B, that is the column heading, and our value is Ben 12C at index 0. Here we passed header equal to none and skip rows equal to 2. Header equal to none and skip rows equal to 2. Then what will happen? The first 2 rows will be skipped, that is RIA and Alvin will be skipped, and this Neha 12B, Ben 12C. These 2 are the data. Now what will be the header? We have used header equal to none. So by default, the positional index, the positional column index, that is 0, 1, 2 will be the header. Here we passed skip rows equal to 1, 2. 1, 2. Now what will happen? The index, the data at the index 1 and 2 will be skipped. Here which are the data at the index 1 and 2? This one, 2 Alvin, 3 Sneha, 2 Alvin 12B, 3 Sneha 12B. This will be skipped. And header equal to none is passed. So by default 0, 1, 2 will be the column header. And the other data, first and fourth row will be displayed. So either we can use skip rows equal to an integer value, then the first n. If skip rows equal to n, the first n values will be skipped. Or we can pass it as a list, then the value at that index, those index will be skipped. Next is index underscore call. This is used to specify a particular column as the row index. Index underscore call is used to specify a particular column in the CSV as the row index of the data frame. Here df equal to pd.read underscore CSV. Then we pass the CSV file along with index underscore call equal to name. Now what will happen? Here in our CSV, see this is our CSV, we have this name, column name here. This column name will be which are the values in the column name, that will be the row index. The row index will be RIA, Alvin, Sneha, Ben. See the name, this is the name of this index, RIA, Alvin, Sneha, Ben. These are the row index. So that is index underscore call. Next is n rows. It limits the rows to read from the CSV file. If we give n rows equal to 2, the first 2 rows will be taken from the CSV file. See, this is our CSV file. If I am giving n rows equal to 2, what will happen? Which are the first 2? RIA and Alvin. See, that will be taken. RIA and Alvin will be fetched from the CSV. That is n rows. Next, sep. See, by default, the separated character in the CSV is comma. Now in the CSV, if we have some other separated character like @ or hash symbol, whatever it is, we can use sep character to create a data frame. Sorry, sep argument to create a data frame from that CSV. For example, here you can see a CSV file. In this CSV file, what is the separator argument? Hash. Right, it is not comma, it is hash. So if we are passing the CSV to create a data frame without using sep argument, what will be the output? See how the data frame will be created. It will be a single column, right? Data frame will be created as a single column. We know by default the positional row index will be added and the data frame is created as a single column. Name hash class hash section. This is a column name and these are the data. And now if we use sep equal to hash. Hash is a separated character in our CSV file. So if we use the sep argument and give the value as hash, what will happen? Data frame will be created properly. See, with 3 different columns, name, class, section and the values. That is sep argument. If we have a CSV file with a separator argument other than comma, we have to use sep argument in our CSV function to create the data frame. Okay, write a program to read from a CSV file employee and create a data frame from it. See, this is the CSV file employee. We have to create a data frame from this. So which function is used? Read underscore CSV, right? First we have to import this, first we have to import pandas, then pd.read underscore CSV, give the path of the CSV file. This is how we create a data frame by passing CSV file. See, this data frame will be created. By default, the row index will be 0, 1, 2, 3, 4. Right? And what about the column? The first value. The first row in the CSV will be the column index. Next, write a program to read from a CSV file employee.csv and create a data frame from it. But data frame should not use files column header. It should not use files column header. But what it should use? 0, 1, 2 as the column header. So here which argument we should use to give the positional index as the column index? Header equal to none, right? Now the first one, employee name, designation, salary. This should not be there in the data frame, right? We are giving 0, 1, 2 and so this should not be there as the data also. If we just pass header equal to, then what will happen? This will be there in the data frame as a data, as a row. And by default, the column index will be 0, 1, 2, 3. So how to remove this? We can use skip rows. So what is the code? pd.read underscore CSV. Then you give the path of the CSV file, comma, header equal to none, skip rows equal to 1. So the first row will be skipped. Then what will be the header? 0, 1, 2, etc. See. If we don't pass skip rows equal to 1, what will happen? Along with the data, the first row will be employee number, name, designation, salary. Next, write a program to read a CSV file employee and create a data frame from it. Use EMP number column as index labels. How to change the index label, row labels of the data frame? How to specify a particular column as a row label? Which attribute is used? Index underscore col. See, we have to give index underscore col equal to employee number. Now, in our data frame, what will be the row index? These values 1001, 1002, etc. See. Next, write a program to read from a CSV file employee.csv and create a data frame from it. But data frame should not use files column header. Rather should use column headings as employee ID, employee name, designation, salary. So how to do this? How to give a specific column header? We can use names argument, right? Names argument, the names equal to the list of the sequence of names inside the read underscore CSV function. See, pd.read underscore CSV, first the location of the CSV file, then comma, names equal to, give the list. And after that, skip rows equal to 1 because here we are changing the column. Already one column header is there, we are changing it, right? So we have to give skip rows equal to 1. Next, consider the employee.csv file. Write a program to read the records from this file in data frame and print the third row stored in the CSV file. How to print the third row stored in the CSV file? So here we can do one thing. We can fetch the first 3 rows and we can create the data frame. Then we can use a tail function to fetch the last row, that is the third row. So we created the data frame by passing the CSV. n rows equal to 3. N rows equal to 3 means the data frame will be created with first 3 rows. Now we will fetch the last row from the data frame so that we will get the third row. Next, storing data frames data to CSV files. Next is how to export the data from the data frame to a CSV file. First we have to create the data frame. After that, export the data in the data frame to a CSV file. Which one is used? Which function is used? To_CSV. To_CSV function is used to export data from data frame to CSV file. So this is a data frames function. See, it is not pd dot, it is df dot to_CSV. Then give the file path. So that data frame will be stored as a CSV file in this file path. File path should contain the location and name of the CSV file. If there exists a same name, same file, it will be overwritten. Default separator is comma. Here in the file, the default separator will be comma. If we want to change the separator, we have to pass sep argument in to_CSV function. If there exists a file with the same name at the given location, it will simply overwrite the file without any warning. So here a data frame is created. See, a data frame is created with column names as name, class and section, and row indexes S1, S2, S3, S4. Now we are exporting this to a CSV file, df.to_CSV. In this location, that is in this location, the name of the file will be df.csv. I'll open this. I'll create a data frame. pd.dataframe. I'm going to pass a dictionary of list. A, the values are 10, 20, 30, 40. Now next is the key B, values are 100, 200, 300, 400. So data frame is created. Now I'm going to export the data from data frame to CSV. How to do that? df.to_CSV. Now we have to give a path. So I will give a path here. The same path I'll give. I want to create the file in the same path. In quotes, we have to give it, replace the single slash by double slash. Now give a name for the CSV file. I'll give cv1.csv. You have to give the type also, that is .csv along with the name. Now, I'll just print data frame. This is my data frame. Now we will see the CSV file. Is it created? Yeah, cv1.csv, that is created. When you open it, yes, this is the data frame and this is the CSV file. Next, sep argument. This set a current delimiter. So as I told, if you want to create a CSV file with some other separator character other than comma, we have to use sep equal to @. So if we need to create a CSV with separator character other than comma, we have to use this sep argument. Sep equal to, then you can give the string. That string will be the separator character in your CSV file, like this. So this is the data frame, name, class, section. Here, what is the separator character? @, not comma, because we passed sep equal to @. That is separator argument. This is an argument of read_CSV as well. Next, handling NaN values in CSV. So here, the NaN values are stored as empty strings by default. By default, when we create a CSV from a data frame which has NaN values, in the CSV it will be stored as empty string. See, like this. This is the data frame, and when I created a CSV from the data frame, see here the NaN value is at S4 and section. At S4 and section it is null. It is an empty string. Now if you want to replace that empty string, you can use the argument NaN representation, NA_REP, and you can give the value as a string. So when we give this NaN representation, see here that string will come. Any string you can give. That is NaN representation. So which are the different functions we use to import and export? So to import data from CSV to DataFrame, we use read underscore CSV. And to transfer the data from a DataFrame to a CSV file, we use to underscore CSV. Here, predict the output of the following code fragments one by one. For every next code fragment, consider that the changes by previous code fragment are in place. Okay, the first one, import pandas as PD columns. Index is given, a data frame is created. Now, here we have created a CSV from this data frame. How the CSV will be created? How the data frame will be created? Which are the column index? This years. And index, these names are the row index. What about the data? Data is not passed here. Only columns and index are passed. So the data will be nan. Right. So the data frame will be created with these columns and this row index with nan values at all the index. Now how the CSV will be created? In that place we can see the column, header and the row, but in data it will be empty string. See like this. This is how the data frame will be created. And this is how the CSV will be created. Data frame with all nan values, CSV with empty values. Now next. Here in question number B, we are updating the value in the data frame. At 2015 and Messi we have 12. 2016 Ronaldo 11. Here 2017 Neymar 8 and 2018 it is 16. How the values will be changed? See. And we are creating a data frame from this CSV by passing sep argument equal to @. So instead of comma it will be @. Here see how it is created. At 2015 Messi the value got updated. 2016 Ronaldo it got updated. And a data frame is created with @ symbol instead of comma. Next. Third one. New data frame equal to pd dot read underscore CSV. Here we are creating a data frame by passing a CSV file to read underscore CSV. So this is our read underscore CSV, the first one dot CSV, which we created from the question number A, right? And here we pass index underscore call equal to 0. So how it will be created? So if we don't pass index underscore call equal to 0, how the data frame will be created? We know row index will be added, right? By default 0, 1, 2, 3. Row index will be added to the data frame like this. Here the row index are added. Now when we pass index underscore call equal to 0, what will happen? Here when we don't pass index underscore 0, the new positional row index will be added, and see these names, they are the values of the data frame now. Right, these names are the values of the data frame now. So when we use index underscore call equal to 0, the column at the 0th index. Either we can pass the name of the column index here, or we can pass the positional column index also. So 0 means it is the first one. First one is name, right? So in the data frame that name will be the row index. See, this is how it will be created. CSV, the data frame. Again in our first CSV, 1.csv, we have all empty strings, so nan values will be there. So that's your wrap for today's session on importing and exporting CSV files using Pandas. See you in the next session. Bye.